Hi everyone, and welcome to this tutorial byte for Oxygen Not Included, which is all about different ways to move materials. The game offers 3 standard ways to do this, with gas pipes, liquid pipes, and conveyor rails, and I covered these in their own tutorial bytes for piping and solid shipping. These have a maximum transfer rate of 1 kg per second for a gas pipe, 10 kg per second for a liquid pipe, and 20 kg per second for a conveyor rail. But there are other creative ways to move materials, and that's what I'm going to look at in this video. And the first way is simply gravity. This doesn't work so well with gases as they form layers by their density, but both solid debris and liquids both fall. It probably goes without saying that this only works to move things downwards. This is commonly done when strip mining, which I covered in its own tutorial byte. When using ladders to dig out large areas, all the debris will fall to the bottom, which simplifies its collection. Using gravity to move liquids is also commonly done, especially early on, to join water sources. When doing so, carefully consider the path the liquid will take, as accidental floods can happen very easily. Of course, you can add tiles to control this better. Now, to quickly move gases, the next method is the bead pump. This works by dropping liquid down a 1-tile gap after being output onto a mesh tile. As the liquid falls, it swaps places with gas packets, pushing them up. This moves large amounts of gas very quickly. To demonstrate the speed, here are 2 containers with 500 kg per tile of gas at the bottom. As I let this run, you can see the left side with the bead pump moves the gas much faster and will eventually vacuum the bottom area. Any liquid can be used as long as the temperature is suitable, and you can do this with the liquid valve set to only 10 grams per second, which is the minimum. For solids, there are a few ways to go faster than the conveyor rail, but other than have dupes manually carry it, you can chain auto sweepers and automatic dispensers together. Each auto sweeper fills the dispenser that's just in range, which then drops the debris just out of range to be collected by the next. This works because auto sweepers can move 1 ton each swing, so is faster than the 20 kg per second of the rail. Be aware that these dispensers cannot dispense food or cooking ingredients, but it's unlikely you'll need to move these in such large amounts anyway. Moving on, the next method is a door pump. This is similar to the door compressor in the tutorial byte for infinite storage. Mostly this is used for gas or liquid, but in theory you could move solid debris with this too. The idea is to squeeze the material along by closing the doors in sequence, and this works in any direction. To explain the automation clearly, here is a spread out version of the doors. Each door is connected to the next through a filter gate and a buffer gate, both set to 1 second. A timer sensor sends green and red, set to 8 seconds for both, opening and then closing all the doors. The filter gates delay the green signal by a little each time, and the buffer delays the red signal by a little, creating a chain. Jumping back to the design I showed, the idea here is exactly the same, but I have laid out the filter and buffer gates to be more compact. Pay close attention to these gate directions, shown by the white arrows. How much is moved depends on the input mass per tile, particularly for gases. It's possible to simply make this wider to move more material, and magma can also be moved with doors made from wolframite, steel or thermium. Also take care with the automation wire material to make sure this doesn't melt either. And another thing to be careful of is overpressurizing the area it's being moved to. As this is like an infinite storage design, if you compress too much liquid here, then it will break the tiles unless you use airflow tiles or airlock doors. The next method is a powerful way of moving liquids, also inspired by an infinite storage method, the Escher waterfall. I explained these in that tutorial byte as well, but using 2 tiles of gas in this key area lets a liquid infinitely fall into the storage area. For moving liquids, we can use this liquid pressure to pump it up, so the liquid literally falls upwards. The rate at which this moves liquids is very high, so much so that it would be difficult to produce so much liquid that this would be necessary. This example shows just how quick this is. I started with a tank filled with 120 tons of water, and it takes around one cycle or 600 seconds to move, so a flow rate of 200 kilograms per second, 20 times faster than a liquid pump. And the final material moving to look at here is magma. You can use either the Dürr or Escher pump methods as shown. As always with magma, be sure to use materials that won't melt when in contact with it, so obsidian and steel are commonly used. But there is also a way to use the liquid pump to get it into pipes. If you simply put the pump in magma, it will overheat, even if you use thermium. There is a trick to pump it though, which uses the odd area that the pump draws liquid from. It doesn't look at the 4 tiles the pump is on, but actually at a cross, centered around the bottom left. We can use this to our advantage and keep the pump out of the magma and in a vacuum, stopping it overheating by having the magma in the tile below. Also note here that the magma passes through a 1 tile high gap, creating a small magma blade, which makes sure it can never rise up and touch the pump. This won't work by itself though, and there is another trick needed. The pump will only pump if there is a liquid on the right tile too. So to do this, we use Viscogel, as it's the only liquid that won't flow and spill into the magma. I explained how to get Viscogel in the tutorial bite for space materials. By placing enough here, the pump will take packets from both liquids in turn. The Viscogel is then filtered out and dropped back into the room. Be sure to keep the magma room as a vacuum, and obsidian or ceramic should be used for the pipes. The Viscogel is also needed to cool the pump to prevent it overheating as it makes heat. I've included a liquid bridge here to transfer the heat into the surroundings, but this may need active cooling later. There are a couple of uses for this, and the first is obviously moving the magma. This could be to clear out naturally formed magma to be used elsewhere, or to combine volcanoes that are far apart into one magma tank for convenience. Beware that when running pipes through areas with atmosphere, the pipes give off some heat. Burying insulated pipes in insulated tiles is a good way to reduce the heating effect. The other possible use is to use the heat directly. If the magma cools in the pipes, they will break, but not if below 1 kg per second of flow. This design uses a liquid valve to run 1 kg per second through a steam room, giving its heat to the turbines and outputting igneous rock at the end. I explain the rest of the build in the tutorial bite for geothermal power. And that's it for this quick look at creative ways of moving materials in Oxygen Not Included. I hope this gives you some ideas, and thanks for watching.